Particles. What are they? We know that particles build our world, such as me and you and those textbooks, phones, and everything. And what is particles? Basically, it's just what builds our world in small dots that gets pulled together by the strong and weak nuclear force, and then have interactions and create what we see. So when in middle school, we learned about the atom. It has an electron surrounding it as protons and neutrons. So that's what we made. Like it made all of us. It made basically all of us. And now we know subatomic particles, which is the electron, the proton, the neutrons. But there's more, a lot more. In the theory, that's called the quantum field theory. Most of its stuff is proven, but not all of it. That's why it's still a theory. People still add to this theory, but it is already like stable. Like a lot of years ago, many people worked on this theory, such as Richard Feynman and then Paul Dirac. So first, we're going to talk about particles that's other than electrons and protons and neutrons. So electron belongs in the family called leptons. Leptons has a lot of fancy particles inside, such as the muon, pion, lots of that stuff. And then we all know that there's charges. The lepton family is most negative charges, mostly. But that's what it is. So then there's the proton. Protons are really, really normal things. They have positive charge. They're basically nothing to study about. They don't have protons that doesn't belong to a family. That don't belong to a family. They're just particles, rudimentary particles, and also neutrons. They are very stabilized and they do not act weird in normal space. That's why you don't see you and me flying and blowing up everywhere. They are very stable. They're built up matter. So also there's a theory that suggests this proton is made by quarks. Little, really, really little particles that is glued together by the weak nuclear force, which is by the strong nuclear force, which is the gluons. And in later episodes, we're going to learn about the gluons, their interactions, the quarks, their interaction, and even antimatter, and even other dark matter particles. And also, we're going to learn about the Standard Model, which talks more about leptons and the other particles. So, let's build up a normal proton. There's three quarks. There's three quarks. We're not talking about what they are just yet. And then they're connected by the gluon. Then with a strong nuclear force, it connects with a neutron. Neutron is built the same way as the proton, which is they're basically the same, although the neutron doesn't carry any charges. Neutral charges doesn't mean that it does not have a charge. It has the charge of a neutral charge. It has equal amount of electron charges and equal amount of proton charges, and positive and negative charges. But you can still alter the proton. Then particles do decay, like like the pion. It decays in a fraction of a second that no one can actually see it because it's too small, and also it decays too fast. And that it emits particles. We can talk about where they come from, how did they come from, and why do they do this in the next episodes. So protons, electrons, and neutrons has really, really, really long lifespan. You can, for the elements, they have more, but there's really, really, really long lifespan. But sometimes, if there's too much particles inside the atom, it probably won't be that long of a lifespan. You can see in the periodic tables, like the nobelium, the 118, which is now called oganesson, but it doesn't have really a name for it. It's the number 118. They're not really stabilized because they're artificial and they have a lot of particles inside their atom. But like hydrogen very stabilized, iron even more stabilized, and then some heavier natural elements also very stabilized, and that's what make us, and that's why us as humans can live that long. Also, to speak about carbon, it's also very stabilized. Also, we're going to put an intro to the quantum field theory. The quantum field theory is a very fancy theory.